Hi, everybody. Michael Silber here, Event Director for Enlit Australia, with another one of our interviews with industry leaders discussing issues around the energy transition. Today, we're very fortunate to have with us Jolyon Orchard, who's the CEO of Luminous Energy. And Luminous is a company that specializes in the development of large-scale solar farms and energy storage systems. And they recently developed the Columboola site in Queensland. Welcome, Jolyon.
Thank you, Michael.
Thanks for joining me today. Hey, I'd like to begin this discussion asking you a little bit about, since you just finished developing the site in Queensland, what do you see as the potential for utility scale solar power generation in Australia?
I think the potential for utility scale solar in Australia is enormous. So Australia has lots of things in abundance. Two of those are relevant to solar generation. One is its solar resource, obviously. So Australia's got some of the best solar resources in the world. I think per metre squared, it's probably got the best. And so that's one very strong attraction for solar developers. And the other is it's got a lot of space as well, which means it's got land availability for large-scale installations such as Columboola. So Columboola is 200 megawatts DC or thereabouts, and there's nothing of that size in the UK, for example, where I'm sitting at the moment. And that's because we don't really have the land availability for it. It might happen. There are some bigger projects under development, but it's difficult, and there are more sort of constraints, I suppose, on a small island with lots of people. So that's less of a problem in Australia and less of a problem in Queensland. So they're two key advantages, I think.
Yeah, I think you've pretty much answered my next question, but can you expand a little bit on that idea as to why Australia is uniquely positioned to be a world leader in large-scale solar power?
Yeah, I think there are some other sort of nuances to the fact that it's got great solar resources and lots of space. One is its proximity to Asia. So, that's something that's being looked at. Developers like Sun Cable Project looking at exporting solar via long distance DC cables to Asia. And it's also being considered in terms of the potential to export green hydrogen to Asia. So I think Australia's proximity to the Asian market is something that could really sort of play to its strengths as an exporter of sunshine in future years. So I think that's important. Australia's also got a pretty sophisticated group of infrastructure investors and the whole sort of ecosystem of advisors and the knowledge that goes with that. So I think there's sort of a setup and an industry in Australia that predates the sort of frantic investment in renewables that we've seen in the last 3 or 5 years, that has helped really support and build that space in Australia.
Yeah, one of the, since you've just recently worked in Australia, you would know one of the biggest challenges with the development of large-scale solar is connectivity, because the farms are built out in the outback often, great distances from the urban centers. So what are your thoughts, or how do you think they can meet that challenge of connectivity to the grid?
Yeah, well, I think you're absolutely right. There's been a lot in the press in Australia recently about challenges faced. I think it's the number one concern of investors and developers at the moment, both connecting to the grid and sort of the timing of that, and sort of the liquidated damages that the EPC contractors can get penalised with if they miss their deadlines, and sort of who wears the risk of that, whether it's the EPC or the investor. And then there's the congestion risk once you are actually exporting. We've seen quite a number of solar and wind projects in other parts of the grid, fortunately not southeast Queensland, but in the Murray West regions in New South Wales and Victoria, where curtailment of operational projects has sort of been a significant issue. And I think something that the project proponents and investors had not really sort of considered to be such a material risk. And then there's also the marginal loss factor as well, which is linked to the sort of nexus between supply and demand. And that's also something that changes on a year-by-year basis, and is quite hard to predict. especially in some areas of the grid. So there are sort of three issues that are all related to your question. And I think that the answer is that you really need to think about where you position your solar power plant very carefully on the grid. And obviously being close to a load centre is very important. And Columboola is about 300 kilometres west of Brisbane, which is relatively local by Queensland terms. It's also near the New South Wales interconnector, so it's got sort of the opportunity to be exposed to some export to New South Wales as and when that's required. And it's also close to the coal seam gas mining loads, so there's lots of coal seam gas going on in the Western Downs region, and that's part of the reason Columboola is such a good substation, because it's recently been upgraded to 275 kV to serve some of that additional coal seam gas load. But yeah, I think being very strategic about where you locate your project is probably a key consideration for renewable energy developers, and yeah, trying to be close to load centres, and also think about the voltage as well. You know, what kV of the transmission or possibly distribution network you want to connect to. So perhaps very big voltages, so maybe at 275 kV you may have less issues. Or you can kind of go the opposite direction and be very small and be almost a distributed generator, where you avoid some of those constraints on the transmission network.
So I think that last answer pretty much answered my next question, which is, give me some of the history of the development, or some of the history behind the development of Columboola.
So yeah, the main draw card for Columboola was its position on the grid network. It also happens to have very good solar resources, but as I said, it's pretty close to Brisbane. We selected it back in about 2016 because it had that sort of access to the 275 kV network on the grid, built into the Columboola substation, which is about 1.5 kilometres from our site. And we understood then that it was a very resilient part of the grid. Actually, when we started developing it in 2016, the MLF, the marginal loss factor, was pretty poor. But we did think that it was relatively stable, and we weren't convinced that some of the high MLFs in the north of Queensland, which also does get the stronger radiation as well slightly, were that robust. And the project did take quite a lot longer to develop than anticipated. And during that time, the MLFs have really been turned on their head. And actually, southeast Queensland is now better than the north, whereas, you know, 4 or 5 years ago, it was quite the opposite. So yeah, to answer your question, I think it was the position on the grid network, but also the relatively high irradiation. And once you start going further west than Columboola, the grid starts to get weaker, and, you know, eventually it peters out before you get too much further. So Columboola is kind of a unique location because it has got pretty good irradiation, being 300 kilometres inland, but it's also a robust part of the grid because of that 275 kV network that's been built to support the coal seam gas.
Yeah, I've heard a lot about cutting edge features on the Columboola site. Can you talk a little bit about that? What are some of the cutting edge features as you see it?
Yeah, so I'd say that the first cutting edge feature that we were sort of really forced into integrating into the project was around the grid connection. And it's pretty difficult to obtain a connection to the grid and to get an offer to connect to the transmission network in Queensland at the moment, operated by Powerlink, just because of the volume of renewable energy projects trying to connect, and also because of some of the concerns around system strength and so on that Powerlink have. So there's a lot of modelling that you have to do to both satisfy Powerlink and AEMO that your solar power plant or renewable energy project will do no harm to other projects that are already committed to generating on the grid. And the approach changed during the course of the development process. So back in 2016, say, you didn't have to sort of undertake and complete all your generator performance standards, which is the way that you satisfy AEMO and Powerlink that your project sort of meets their criteria. And so we had to sort of go through a very rigorous process and faced a lot of challenges along the way. And I think, yeah, that sort of forced us to innovate. And we were fortunate enough to have SMA providing the inverters and providing support there. And we had a very good technical team of consultants at GHD who provided us with grid support modelling and some other members of the team as well. That meant that we were able to sort of get through some of those challenges. So that was one area. And then the other area, which was pretty innovative 2 years ago, I suppose, when we first started looking at it, but is pretty much now the case on all Australian projects, I think, solar projects, is the use of bifacial modules and trackers. So there aren't that many projects that have actually been that reached financial close or been commissioned with bifacial modules, but Columboola has sort of considered the use of those from about 2 years ago, and we installed an albedometer on site back then in 2018 to start measuring the generation off the rear side of the solar panel that we'd expect to receive from the albedo, which is the reflectivity of the ground on the site. And so, yeah, they're probably the two key features I'd say.
Yeah, I'd like to know a little bit more about, I'm very interested in the PPA, the power purchase agreement with CS Energy, whose CEO, by the way, Andrew Bills, will be speaking at our conference in March. But tell me a little bit about the significance of that PPA, and particularly as it relates to delivering reliable power to Queensland.
Yeah, well, I suppose the first thing to say is when we were initially developing the project, we had planned to develop it on a merchant basis, so to get the project to financial close on the basis that it could make a decent enough return selling power on the spot market. But because of the delays that the project faced, that model kind of no longer worked in 2019, 2020. And that's in large part to the success of solar in Queensland, especially rooftop and other utility scale projects eroding the price of electricity, which is a good thing for consumers, but a bad thing if you're trying to get away a merchant solar project. So we really needed to find a power purchase agreement to bring the project to fruition. And so the significance in CS Energy signing a PPA with the project was obviously very high. So the PPA, I think, was initiated by a group of several universities who were all CS Energy's customers, who wanted to procure green power. And so the setup is essentially that the solar farm will sell 100% of its output to CS Energy, so that's about 450 gigawatt hours per year, or enough electricity to power approximately 100,000 Queensland homes. And CS Energy will then firm that solar output with its own fleet of conventional generation, which is mainly coal, and sell that on to their university and other industrial customers.
Terrific. And my final question is really, tell us just a bit more about Luminous Energy and any future plans you might have for Australia.
Yeah, so we're a UK-based developer. So we started life in 2013 developing solar projects in the UK. Back then there were subsidies to support solar, and in 2016 those subsidies came to an end and we started to look at international opportunities, and Australia was an obvious choice. It has many of the advantages that I spoke about earlier in the interview, and also at the time had the renewable energy target, and what we still feel is a pretty solid outlook for renewable energy going into the future. I myself also lived in Australia for 5 years, so I had sort of a history and an understanding of how things worked in Australia. So we started developing solar projects in Australia then, and will continue to do so. Luminous has also been developing projects in Chile and the US, and we've also developed several energy storage projects. Energy storage is also something that we're interested in potentially doing in Australia, and yeah, that's a potted history of Luminous for you.
Jolyon, really appreciate your time. A great interview. And hopefully I'll see you out here in March 10th and 11th. We have our live event in Enlit, Australia. And so good to meet you. And again, thanks for your time.
Likewise, it's been a pleasure. Thank you, Michael. Bye-bye.